Three big things changed at once. Agents got a better way to judge their own progress, a cleaner recipe for training them from open data, and a true language world model that can simulate what happens before an agent acts. That matters because the bottleneck is no longer just, can the model talk? It's, can it plan, recover, and improve through long horizon interaction? Across these papers, the trend is moving from static benchmarks to agentic systems that learn from trajectories, not just answers. Keep watching, because the details reveal where training, evaluation, and simulation are finally starting to line up. Let's explore the first paper. Neglected free lunch from post-training progress advantage for LLM agents. Neglected free lunch from post-training progress advantage for LLM agents from the University of Wisconsin, Madison, and Argonne National Laboratory argues that RL post-training already contains a free process-level signal for agent evaluation, eliminating dedicated process reward model training. The paper derives progress advantage, the log probability ratio between an RL trained policy and its reference policy, and proves that under a stochastic MDP, it exactly recovers the optimal advantage function, while the exact implicit reward fails to telescope because of stochastic environment transitions. This signal is applied without task-specific training to test time scaling, uncertainty, quantification, and failure attribution on BFCLV4, MT, WebShop, Agent Dojo, Tau2, Bench, and Who and When across Gemma 4, Qwen 3, 5, Quendry, and Omodri families. In best of 8 selection, it reaches an average success rate of 38.8 on Gemma 4, 4B, and 62.1 on Qwen 3. 5.9B, exceeding training-based baselines such as Wild Reward, 8B, and Think PRM, 1.4B on Tau2. Bench AUROC, it attains 0.865 on airline and 0.69 on retail, with Gemma 4.4B and 0.72 and 0.678 with Qwen 3.5.9B. For a task-specific web shop comparison, progress advantage reaches 35 success rate versus 33 for agent PRM 7B, and a GRPO-tuned variant reaches 38. Let's explore the second paper, Open Thoughts Agent Data Recipes for Agentic Models. Open Thoughts Agent Data Recipes for Agentic Models presents a fully open data curation pipeline for training agentic language models, developed by researchers from UC Berkeley, Stanford, UCLA, Microsoft, Amazon, and related institutions, and benchmarked mainly with Qwen 3 models. The paper's core contribution is a 6-stage supervised fine-tuning recipe, validated through more than 100 ablation experiments that show task source choice is the dominant lever. Stronger models are not necessarily better teachers, and keeping longer multi-turn rollouts improves learning even at a matched 144.76M token budget. Using a 100K example dataset distilled from sources such as Smith, Stack Exchange Superuser, Stack Exchange Tezos, and issue tasks, the authors fine-tuned Qwen 332B to Open Thinker Agent 32B, which reaches 44.8% average accuracy across 7 agentic benchmarks, including 54% on SweBench Verified and 26.2% on Terminal Bench 2, outperforming Nemotron Terminal 32B by 3.9 percentage points on the 7 benchmark average. The data recipe also scales. Open Thoughts Agent V2 expands Tezos task diversity from about 902 to over 21K surface forms, and keeps improving up to 100K rows, reaching 55.7% on SweBench Verified 100 and 26.2% on Terminal Bench 2 at 32B scale. In parallel, the reinforcement learning study at 8B scale shows that the RL data source strongly changes behavior. The best source, PyMethods 2 test, yields 35.67% on SweBench Verified, 16.02% on OTTB Lite, and 13.48% on Terminal Bench 2, while the full SFT plus RL pipeline reaches 27.9% average across 7 benchmarks and improves over the Qwen 3.8B base by about 18 points. Let's explore the third paper, Qwen Agent World Language World Models for General Agents. Qwen Agent World, from the Qwen team at Alibaba, is a native language world model built to simulate 7 agent environments: MCP, Search, Terminal, SWE, Android, Web, and OS using long chain of thought next state prediction rather than post hoc agent fine-tuning. Trained on more than 10M environment interaction trajectories with a 3-stage CPTS FTRL pipeline, it couples continual pre-training with explicit reasoning activation and GSPO-based reinforcement learning, then evaluates on Agent Workbench, a 2,170 sample benchmark drawn from real executions of 5 frontier models across 9 established benchmarks. The flagship Qwen Agent World 397B A17B reaches a 58.71 average on Agent Workbench, surpassing GPT-5-4's 58.25, while the 35B model climbs from 47.73 to 56.39, an 8.66-point gain over its base checkpoint. As a decoupled simulator, the model improves simulated OpenClaw training, lifting Claw Evolve from 65.4 to 69.7, and QuenClaw Bench from 47.9 to 55, and controllable simulation boosts Tool Decathlon from 32.4 to 36.1, MCP Mark from 21.5 to 33.8, and Wide Search F1 by item from 34.02 to 50.31. As a unified agent foundation model, single-turn LWM warm-up transfers to multi-turn tasks, raising Terminal Bench 2 from 33.25 to 39.55, SWE-Bench verified from 64.47 to 67.86, and BFCL V4 from 62.29 to 71.25, while explicit next state prediction accuracy improves from 69.9% to 78.3%. That's a wrap on today's AI paper highlights. Thanks for watching.